Yeah. Anyway, can you see?
It looks very good. And I think we are
Great.
live.
So
This is it's August 31st, 2023. And we are about to look at some metadata.
yeah, so basically, I'm gonna jump between windows, so I'm sharing my entire desktop. So to be quick about it, this is all what I want to present next week. But basically, what we did is that we have contacted a bunch of coffee growers in Honduras, and we want to sell their coffee in the United States. And we created this thing called the origin certificate. It's just an NFT, but it captures the properties of the coffee that we are intending to sell. And the idea is that these certificates will capture this information, and over time, the coffee growers will have like a record of their quality, of their different sales, and all of that. And on top of that, we want to build things like credit, access to markets, and other stuff, right? So this is the first small pilot, I suppose. Anyway, this is how the metadata shows on Cardano Scan when we mint one token. But the problem is that wallets are not picking this up as an NFT. It just shows as a fungible token, and then the name of the token is just the asset name. And well, it basically is in the completely wrong category. Another thing that is happening is when we transfer this token to another person, for some reason the metadata gets caught, and it I don't know, it appears as like a shortened version or something like that when you move it to another wallet. So if I send an already minted token to another person, a portion of the metadata disappears. I'm not sure why. Anyway, so here is where we have, so we're using Lucid. In a portion of the transaction construction, we have the metadata just hard-coded like that. And then we just import the Airwave ID from a database, and the policy ID we also import from somewhere else. And here later in the transaction construction, we just attach the metadata and the label. And that's where we are. And here is where I copy what shows on Cardano Scan to VS Code. And obviously a bunch of errors got flagged. And I was trying to put them in a more standard zip25, but I'm still getting errors.
Good. This is a perfect problem to look at. Can you go back to the coffeemint.json file?
Sure.
The one on your far left, I see coffeemint.json, the generated file. And that string on line 16, how many characters in it?
Not sure.
Just in between the quotes.
Okay.
63.
Yeah. So that's going to exceed the limit, right? The longest string you can have in metadata is 56 characters. Or is it 64? Shoot. Anybody? Sorry, I get these two things confused. Is it 64 or 56?
Is that in the SIP25?
Just metadata in general. Yeah. So this would impact SIP25. Maybe it's a 64 limit right here. We got to look at that.
Is it here somewhere?
Gonna
look for it.
Yeah. There should be something about using an array for strings long. Oh, there it is, 64 characters. Okay, good. So we're actually fine in that case. That's great. The other thing, a really, really good tool is the Pool PM metadata test tool, where you can go and see if your metadata is well formatted. Have you used that before?
No.
Go to this URL, go to poolpm/test/metadata. Hey, man.
This is exciting.
Pool.pm, how does it go?
Mhm. Yeah. /test/metadata. And then what you can do is you can just drop your metadata JSON on the left and you can see how it renders on the right. Great. And right off the bat, what you'll want to do is wrap everything you just did right there in one more set of curly brackets.
From the 721.
Yeah, from before the 721 and then from after the end of the last one. And put a colon after the 721. Okay. This is basically what the format is going to look like. And if you look at SIP 25, you'll see that this is the format we're following. Okay. But for some reason, it's still saying unexpected at position 1. So maybe we should clean this up first in VS Code and then paste it in here again. So we know we want.
I was trying here.
Oh,
This
here.
is what I
Yeah,
have.
good. Good. So you've got these enclosing brackets. It looks like that set of blue brackets on lines 4 and 31 is extra. Or maybe just the one on line 4 is extra.
This one.
Yep. And then we could probably get rid of the comma on line 27. And then all of those key names on lines 5, 16, 18, 19, 20, etc. Put each of those in quotes. So in JSON, long story short, it's not always necessary to have those in quotes, but in on-chain metadata, it is.
Okay.
Do the same for version and then media type, name, and source. It looks happier about that. Oh, you need a comma after line 27. Sorry, I think I had you remove that a moment ago. Good. All right, let's try that at the pool PM test. Cool. All right, so now we're getting everything but the image. That's a good step to be at.
Yeah, the R with links not working.
So that doesn't look right, the Arweave link there. Now go back to your original JSON file that you had us on a moment ago.
Yep.
And grab that URL instead. Let's see if that one works.
Yep.
There we go.
So now at least here's the outcome you're going for. And now it's a matter of making sure that you can automate to this step correctly. But at least you can rest assured that this is doing the thing you wanted. Now, I did notice at the top, just back on Pool PM for one moment, you see how there's no thumbnail. And
Where? Oh, okay.
at the top, it's like it says the word thumbnail, but that's blank. And then right underneath the title, origin certificate, there's that little frame right there. I'm not sure what that represents. So you might want to just go back to the SIP. And that's why you notice how you're adding the URL for the image 2 different times. I forget which one is the thumbnail and which one is the full scale image. Right? You've got file. You've got this file thing and you've got this image thing. And one is one and one is the other. I can't remember which one is which. Anybody know that? Now we can look that up. And then another thing you can play with here, I see that your description is a list of strings, and that's fine. But you also have the freedom to create any key value pairs you want to. Okay, so like within origin certificate, for example, if you wanted to give each of those fields a unique name, you could. And if you did, one benefit of that would be later on, now those are just accessible properties instead of indexes in an array for people building front ends around this.
Oh, I see. So if I make each of those in the description like a little mapping, then
Exactly. Yeah. Right.
okay.
You could change those square brackets after description to curly brackets, or you could even remove the word description and just have a set of fields. But that's a matter of taste. That just depends on the use cases you have in mind.
Yeah, I mean that probably would be good later if you want to search from coffee varieties and get different certificates. Yeah, that would be quite useful. Great. Well, I guess that's that. Thank you so much.
We made short work of that. I love it. What questions does that raise for everybody else?
Well, I'm digging through that the SIPs.Cardano SIP25 documentation, and that's kind of cool. I'd never seen Arweave before.
Oh, we like it more because it's cheaper than IPFS.
Okay.
And here is our validator in icon if anyone has any questions about it.
And is this?
Yeah. Cool.
Say that again.
These are validator.
Okay.
For minting the tokens. So this is, yes, you're using SIP25 to put a visual component to your tokens on chain, but for the minting script itself, you're using a smart contract and not just a native script. Yep. And this allows you to distinguish between, so what's the difference in the minting between basic and premium tokens?
Just the quality of the image, because we generated 1,000 images with a private AI generator tool that costs money to use. So we only created 1,000 of those. And then for the rest of the 4,000, one of our developers just got one of the open source versions of, I don't remember if Journey or one of those. And he runs it locally on his system, so he can generate as many images as he wants. But those sort of a lower quality, lower detail. Let's see if we can look at the difference in the website. Here is the gallery. So the idea is that you go here and you choose one of the NFTs. Takes a while to load for some reason. I need to optimize that. Or I just have too many tabs open.
So there's a premium level that's capped at 1,000 that are generated with this special private AI with like super detail, and then there's another sort of less rare.
The remaining 4,000 are like this.
Yeah.
That have obviously less detail, and the premium ones are these ones that have more detail. So that's the only difference. And obviously they're not going to have that watermark. That's just there so people don't copy.
Interesting.
It's very cool.
Yeah, and here's someone in the icon Discord alerted us that we don't have any way to stop an NFT the validator basically minting two NFTs with the same asset name?
Yep, that's a good problem. Yeah.
I think we were just going to do that off chain, basically just control it on the server side. I was not sure if we can do it directly here, but that's another thing we have to look into.
Mix, what are your latest thoughts on token naming and unique name duplication?
First of all, hello everyone. The idea I'm working is Merkle tree. So the idea having a Merkle tree on blockchain and using each UTXO as the node, and then each UTXO will have some parent hash, like the relationship with the other UTXO, and sibling hash, and of course the child. The problem for this distributed Merkle tree, first is the limitation of datum, but we can overcome that by actually old school solution, the datum hash. So instead of putting everything in line inside the datum, we can just use a hash and provide that datum in the transaction. Although that will raise the question of, well, now the transaction size is the problem. So what if we will hash a JSON file, and then we will use that hash as a datum, and then hashing that datum and putting that in on chain? So it is possible, it is feasible, and I'm working on that, but there is a problem of search. There is a problem of verifying that uniqueness. So the thing maybe that's the only solution, because the contract in Cardano, they are not stateful, so they cannot do the search function and looking at all this UTXO. So it is possible, but the transaction size doesn't allow you. So for example, you cannot insert like 500 UTXO inside a transaction as a read-only, as a reference, not a spending, and checking that does this token name is unique or not. So it is, since it is not possible, we have to come up with a distributed engine, which Ada Handel also called that. And that engine means, imagine like 30 pools, or I don't know, 100 pools, or each person who mint that token, they are obliged to protect that. How to do that? They are going to help this search function by providing a very small API or something. I don't know, maybe I'm just thinking about that. They will participate in that search. They will participate in that mutual consent between all the token holder. And after that, confirming from all these nodes, I mean, they don't have to go to the top, because each leaf can just verify its direct descendant or ascending, or its ancestor for coming. For example, I am at the level of 32, which means around 4 billion tokens, if we have that. So if I am at level of 32, I just need to verify 32 parents or grandparents of me. That's all. I don't think it is even a computation consumer. I just need to verify 32 hash are actually correct. So I think maybe this is a solution of distributed Merkle tree, where people will post the hash of actual Merkle tree, and they will just verify their own token uniqueness. And if it gets enough verification, by adding a multi-sig contract. So imagine that consent, that agreement approval is just a bunch of PubKey hash. So if someone wants to mint a token and wants to check that is it unique, he just need to get 3 out of 5 PubKey hash, like signature. From whom? From its siblings or parents, or all of these things. And if it gets that, the network itself will prove that it is unique just by participating other people PubKey hash into that minting. So first, it is decentralized. It is kind of permissionless, but maybe we can say the blockchain, even the blockchain itself, it is not permissionless, because all those nodes, or at least some amount of nodes, must approve that. So they should permit that transaction is valid. But we can discuss about that. And above that, the network itself, the people who mint that will protect themselves. I think maybe that's kind of a solution for that, but really so cool. Still I haven't found a smart contract way, because there is a linked list, but there is a problem of concurrency. But in that distributed Merkle tree, we don't have concurrency. And as much people as they like to mint, actually that will solve that concurrency. Like each level increase, it will solve that concurrency by factor of 2. Because once you have 2 node, it means 2 UTXO. And if you go to level 3, exactly. So if you will reach level 32, imagine just 32 hash you have to say it is correct. Right. Around this, it means 2 power 32. That's right. Number of tokens. So
like you said, I mean, what's cool, so like it's a hybrid solution, right? Because on one hand, we can validate the soundness of the entire system with simple Merkle tree hashes, and those can go on chain for a low expense. But if we also want searchability of that entire database that's represented by that hash, that it just doesn't make sense to put that on chain, right? We can verify that that database is correct anytime, but if we want to be able to search it, there's going to be a server somewhere with that information.
But if we distribute that, if each person wants to mint something, they have to reference some other old UTXO, and let's say just 10 or 5 or something, that would be enough for minting.
Yeah. And now, I mean, I think it's worth framing this problem a little bit historically, but to start at kind of the most recent problem, this really only matters at the moment of minting, protecting against really concurrent minting, right? Because like at the end of the day, that searchable database we're talking about just is the list of tokens with a certain policy ID, and that is on chain, right?
Yeah.
But what we want to ensure is that at the moment of minting, what is the mechanism by which you can't mint another token with a duplicate name?
Well, that's it. Who comes first? Right. So I was thinking that maybe we can incentivize people for that. So not only you will protect your token name in that Merkle tree, in this whole scheme, but you will get incentives, maybe kind of something out of this thing. And the incentives would be if you provide this service to the people who wants to mint, and you need to work with others. You need to, your UTXO should work with your siblings and your parent and of course your child. But imagine that if there is this incentives of increasing your children. So if you get this you have two leaf, and I think you guys have heard this. I mean, I'm getting this idea out of this network marketing, all this ML, I don't know, this scam, they are saying if you sell this and if you sell to two other people, you will get this much of. So imagine same thing with that. So the thing is, people will try to compete. And again, there should be this randomness, like who should mint first? Like I want to mint Gimbal's name, and there are two people. One is, I don't know, in leaf number n+1, another in n+-1, and at the same time they want to mint. Maybe the system can randomize this. Same thing, same code we can use from Cardano. Like we have that code, we have in Ouroboros, we have the code of randomness. Maybe we can use that Haskell code for the off-chain for creating this randomness. And that randomness will choose whom based on, like inside the Cardano, if you have bigger pools, you have the high chance to be selected. But in that Merkle tree, if you have more children, you will be selected. If your side of all the token name, if you participate in that Merkle tree more, then that function, that off-chain function, which everyone agree with that, because we can create a tool, same thing with the Cardano. There is this Cardano nodes, new version, amazing features, great. But if majority of nodes or pool operators do not want that, it doesn't matter. So same thing. There is a Cardano, like there is let's say, I don't know, something CLI or something node, the name of the project, and there is this again consent between the people inside that. So I think maybe there are some logical problem in that, but I think we can duplicate what has been done within Cardano and kind of convert it to make a project, an NFT project, and use it not only to make it decentralized, but distributed, and giving this power of protecting this project to the people who mint that. And again, there is these incentives. There can be all sorts of incentives for that. I don't know, because all these UTXO will be inside a contract. We can lock that in that contract, and that, imagine there is these two ADA for each of that leaf or nodes, and imagine there are like 60 million something. And sure, there will be a pool reward, there will be a staking reward. So who should get that staking reward? The people who participate more in that network, who their children, like the tree grow more from them. And the contract itself, the rewarding contract, certifying contract, staking contract, can approve that. Actually, again, how do we do that? How do we have a UTXO that say that? Again, there can be a multi-sig consent. Like there can be a bunch of pub key hashes in each level, and if someone gets 5 out of, I don't know, 10 or 3 out of 5 or something, can update its datum, and its datum say that, hey, this guy now is, I don't know, like level something. Therefore, he is obliged to get this much reward from all these UTXO locked in that contract. It's just, hypothesis I have.
Right. Well, so this takes us very deep into like system design, and I think it's going to be really interesting to keep getting people to understand the different network components to make a system like this work. But maybe to pull us back a little bit towards where we're at learning. The whole reason this is a concern is because of the massive potential of moving to Plutus-based minting. And so everybody who's moving through the course, you're learning different ways to mint tokens. You're learning about native scripts, you're learning about Plutus scripts. With the original Cardano NFTs, it was easy to not duplicate names of tokens. If I wanted to mint, say, 5,000 space buds, for example, I would just mint them all at once. And it was on me as the minter just to make sure they all had a unique name. Okay.
Yeah.
And once those are minted and the policy is locked, there's nothing to worry about, right? 5,000 tokens, 5,000 unique names with unique artwork. Great, let's sell them. And at the point of selling, what would happen is the buyer of the NFT would pay to a wallet and they would receive back a token that was minted some time ago, right? Now, with Plutus minting, this is different. What's amazing about it is that people can mint tokens on demand. We can build transactions with a front-end library like Lucid or Mesh. And then we can allow users to come and say, okay, well, I'm going to submit a transaction that mints a token. Everybody who's taken this course did it with their contributor token. Right? And we could look at how that naming is not secure. It would actually be easy once you know how to use Cardano CLI to mint a duplicate token. And we want you guys to understand that. Right? But now that we have this ability to use Plutus very elegantly to mint tokens on demand, a problem that a lot of people are addressing from a lot of different angles. This is, I think, a great place for research and innovation right now, and people are doing it, is okay, if I have an on-demand minting contract, I can make it so that people can only mint one at a time. I can make it so that people have to send, 25 ADA to this address. All of that's easy, but how do we ensure that people can only mint a token whose name does not yet exist on chain? That's the hard problem right there.
About that, I remember that in Academy, one of the guys that graduated, he created the Merkle tree you were discussing using Plutarch. Not for names, but for subscriptions, basically to track people that subscribe to a service or something like that. So probably he could help. I could try to get his details if you guys want.
I should say that people maybe think that, okay, Merkle tree, no, we have different kind of Merkle tree. For example, in Handshake, we have top to bottom or, ADA handle, because the hash grows from top to bottom. Some other Merkle tree or some other project, actually they come back from bottom to up. So there are different sort of Merkle tree. And I should add this point up. In terms of legality, after we search something, especially in US, if you mint like 500 NFT or something, and then sending that to someone, now you are in trouble actually, because they can say, oh, it is a security, you sold something, you need to pay taxes, all sort of things. But if you provide a contract to them and just guide them and say, hey, this is how you can mint, and if they choose to mint that and all the code itself, they say, yeah, the person themselves mint that, even in legality, they cannot charge you or they cannot hold you accountable. Like, okay, you have to pay something. No, you can say, hey, I just made like an ATM machine or printing machine. Someone came, put some, I don't know, cent or dollar inside the machine, and they printed. I just made the machine. He had all the reason to not or to do it. So the Plutus minting is not only the way for, the actual good minting, but even the legality of any NFT project, you should really care about that. But how do we protect it? How do we protect that flexible minting or distributed minting? Well, that's open question. So far, we the most maybe simple solution would be using a multi-sig contract, a multi-sig minting contract. Whether the project owners will provide that extra public hashes or extra signature, or other member of that group or that project will provide that. Other than that, I'm maybe that Merkle tree, like off-chain Merkle tree, which it's represented by hash, and that hash again represented by another hash inside the UTXO would be maybe
Actually, I have an idea for, I mean, we've got almost 40 minutes left before we have to break today. And mostly a crew of people who have been working together for a long time here. If nobody has immediate questions about the course right now, would anybody be interested in looking together with Mix at what we've been working on for Handshake?
Yeah, that would be great. I
Can we
can show
jump to
you a
that?
lot of nice.
Yeah.
I mean, some of the bash script and the whole logic, of course. Actually, we have a staking contract as well. So I would love to show you.
Let's see how much we can catch up on. I'm gonna stop the live stream just so we can kind of keep this work close now. Anybody watching this video, we are working on a project that we're really excited to share more about. We're not quite ready to share about it publicly, but coming soon from Gimbal Labs and some other great developers across the ecosystem. As for live coding, we meet every Wednesday and Thursday at 14:30 UTC. So that will continue next week. And we will publish module 301 very soon, within the next few days. So looking forward to that. All right, take care.